Chapter 1, Section 4, learning target for today is solving equations. So when Mr. Bradley walks up to you and says, what was your learning target for today? Solving equations. He will.
He asked me yesterday. Well, you had yesterday, hey? Friday.
All right. All right. Solve by setting up and solving an equation. Two planes leave San Antonio at the same time. The northbound plane travels 70 miles per hour faster than the southbound plane. Nope. The planes are 1,940 miles apart in 2 hours. How fast is the southbound plane flying? Read the title of the problem. What's your question? Depends on the speed.
No, they're both going the same.
Which one? What's the closest distance between 2 points? A straight line.
See our old science sheet before Kurt was trying to tell me that the plane that goes this way is quicker than
It could be. Depends on what the I'm in brain lock right now. The jet stream is doing. No. Hey, listen. And if you're using it here to here, right? They're going from this point to this point, right? Could this one get here faster than this, going the same speed? If the jet stream is moving like this, yeah. You mean you're riding in dead air? I'd like to see how that would work then, because I don't believe it would. The shortest distance between 2 points is a straight line.
Because she literally kicked me out of my class.
You probably had it coming. Okay, read the following problem. What process are you going to use to solve this problem? What process are you going to use to solve this problem? 2 planes flying. What process? What equation would you use? What equation would you use? What equation uses distance and speed and time? Distance equals what? Rate times time. Have you ever seen that equation? You're going to see it today. Distance equals rate times time. Distance equals rate times time. If I am going 50 miles per hour, driving for a half hour, how far have I gone? 25 miles. All right. If I'm driving 50 miles per hour, and I've gone 25 miles, all right, how fast have I gone? How far have I gone? 50 miles per hour. Oh, I'm sorry. Yeah, I'm going backwards on this. I drove for 30 minutes. I'm sorry. I drove wrong one. 50 miles per hour. What? 50 miles per hour. And you can write this as this too. And I would suggest, if you're doing this, write it this way: miles per hour. And here's why. And I'm going for a half hour, right? How much is a half hour? 0.5 hours, right? 0.5 hours. Notice you have an H on top and an H on the bottom. They cancel each other out. What am I left with? Miles. What's 50 times 0.5? 25. 25 miles. All right? So we're using our distance formula to be able to figure this out. What is the formula that rates this? Well, it's distance equals rate times time. Okay? down.
Formula.
All right. Distance equals rate times time. All right. Define. Why can you represent the rate of a northbound plane with the algebraic expression x plus 70? In other words, the rate of the southbound plane, let x equal the rate of the southbound plane, but this one is x plus 70. Why can you do that?
Because the northbound plane is 70 more than south.
Yes. Its rate is 70 miles an hour faster than the other plane. So we've got one plane going x miles per hour and one going x plus 70 miles per hour. Okay? What does the expression 2x represent? 2x plus 2 times x plus 70 equals 1940. What are we representing here? Remember the equation, rate times time. Yes. What's the 2 represent in this case? Hours, right? 2 hours. We're going 2 hours in this case, so we're going a rate of 2 hours, we're going a time of 2 hours times the rate, which is x in this case. So that's one plane. The other plane is flying 2 hours, and its speed is x plus 70. All right? And how far do they go? Together, 1,940 miles, right? Together, they're going to go that distance. So, if we took 2x equals one plane, okay, and then 2 times x plus 70 equals the second plane, then together their distances they'd go would be 1,940, and we add these two together. All right, so what does it represent? Total distance. Why do we divide both sides by 4? Why would we divide both sides by 4? In other words, take a look here. What did we do here? We took the original equation. This is the distance of one plus the distance of the other is going to equal this distance. But then we got rid of the parenthesis signs here, right? Carried the 2 through. 2 plus 2x plus 2x plus 140 equals 1940. And then we added these two x's together to get 4x. Why would we divide that by 4 then? Yes. So we would be left with just an x. All right. Now, one way we showed you, and I showed you before, is I would subtract this 140 from it and subtract 140 from this side. So I would end up with my 1800. 4x here equals 1800, right? And now I would divide this by 4 because we're trying to get this x by itself. So we get x by itself. And what would our x end up being? 450. What does this represent? What does 450 represent in this case? Reese. There you go. It's my speed of my first plane, right? How fast is my second plane going? 70 plus 450, right? Right? So my second plane is actually going, one is going 450 and the other one's going 520. 520. Okay? And then the answer here, the southbound plane flying at 450 miles per hour. How can we find the speed of the northbound plane? We just did 520. Add 70 to it, and we found it. Okay, this is how we can break down. That was one problem, but we broke it down piece by piece. All right. Let's go into next practice. What's that? That was a lot of stuff. Yeah. So, yeah, this is 4.2. This is practice. We're just going through it. I'm going to do a couple of these. I'm going to let you guys do the assignment, and then you go on. 4.1 and 4.2. All right. If I'm going to solve this equation, what do we do? Let's start off with Katie. Number 1. How would I solve that equation? Subtract 7.2 from both sides. And what will we end up with? We're working with decimals now. What is it? No. If we subtracted, here, watch how we do this, guys. If I subtract 7 from 19, what do I get? If I subtract 7, if I take 19 minus 7, I get 12, right? Now we got to subtract a 0.2 from it. That's what's left over here. 11.8. All right? Subtract what's on this side of the decimal first, then what you have left over, you subtract this side of the decimal next. And that'll help you figure out what the answer is. Okay. Number 2, Fletcher. As soon as you're done there.
I don't think you did that right.
Divide by 5 on both sides. So it is done right. Right here. 19 minus 7.2. You're taking 19. Well, this cancels this out. Okay. Do you see how we got it?
Yeah, I got it now, man.
All right. Fletcher, we divide both sides by 5. What do we end up with? A trick to this is, don't look at the decimal right now. Take 85 divided by 5. All right? How many times does 5 go in 8? 1 time, right? What are we left with? 35. How many times does 5 go into 35? 7 times. Now we can put the decimal in here. Decimal goes there, so we move it over 1 spot and put it there. So our answer to this is 1.7. See how we do that? Go ahead. Nikki. Number 5. What's the first thing we do with that? Right here? Yeah, I'm not worrying about these right now. There's a z in there, but 9 times z would be 9z. 9 times your 3 would be a minus 27, right? Equals 12z. All right. Add 27 to both sides? I would bring my 9z over and just leave my 27 there. Okay, so what would I end up with? So I subtract 9z from both sides, right? And I would end up with what? 3z equals negative 27. And then what do I do? Divide by 3. Z equals -9, and that would be your answer. You see how we did that? It's order of operations. First thing we have to do is get rid of those parentheses, carry the 9 through. And then we combine like terms, right? Once we combine like terms, the z's, then we can get rid of any number that's sitting out in front of that z. So we can put z by itself and come up with a number. Reese, how about number 6? Yep, what would you do? So I would add them. I got a plus and a plus now. How would I do this? Would you minus 6y from here and minus 6y from here? And then what about your 5 and 11? Bring your 5 over, right? Minus 5 here, minus 5 here. Let's figure this out. 6y minus, or 7y minus 6y? Y. This goes away. This goes away. 11 minus 5 is? 6. There you go. Y equals 6. Got her? Cool. All right. Go ahead and work on your assignment. Let's take a look here on your assignment. I want to make sure that we have, get rid of this. I hate it when that happens. Yes. I want to see, what do we got in there for number of problems?
12 in the first one.
Let's see.
12 in the first one. We don't know how many.
Do the odds. Do the odds for this. See, 4, 2. I didn't want that. I wanted 4. Eight. Let's see. Yeah, do the odds. It'll leave you about 10 problems to do.